Good morning. Welcome to week. I have absolutely no idea. Eight maybe of distance learning. I'm not 100% sure. But we're getting there. Seems like Groundhog's Day over and over and over again. So let's get into what we're going to do today. I tried to spice it up a little bit, jazz it up a little bit. So I threw in a couple of jokes here. We got a little XY up here. Say, Cube, do you consider yourself to be religious? I believe there are higher powers than us, if that's what you mean. Hopefully you got that. Next one, we're dealing with exponents. So exponents. So the kid's like, why did they quit being ponents? Let's see if you can figure that one out. All right. So today we're going to work on multiplying exponents or multiplying powers. It's really a simple concept. I'm going to go through why it works, and then we're going to look at what the actual algorithm is to make it life a little bit quicker. For you, calculations a little bit faster, but I just want you to understand where it comes from. So let's look at this one, 3 to the 4th times 3 squared. So what does this actually mean? So 3 to the 4th means 3 times 3 times 3 times 3, and 3 squared means 3 times 3. So if you notice, this is just one giant multiplication problem. The blue represents 3 to the 4th, red represents 3 squared. Well, written this way, you can clearly see it's actually 3 to the 6th. So what we're going to do is look at a way to get from here to here pretty quickly. Well, let's think about it. How are 4 and 2 related to 6? Correct. From first grade or maybe even kindergarten. 4 plus 2 equals 6. So when you're multiplying, two bases that are the same, okay, what you're really doing is you're just actually adding the exponents. And why is that? Well, this is the first one written out. That's the second one written out. And when you put them all together, because you're multiplying, you stick a multiplication symbol there, you wind up just having that many. You just count all of them up. Okay, so it comes out to be 3 to the 6th. So the actual algorithm for this is, now we use just the variable a, and that just represents some kind of number. It could also be a variable in and of itself too. So anytime you're multiplying same base with different exponents, it could be the same exponent, by the way. It doesn't have to be that, but just exponents. What you do is you just take a, that base, and then you add the two exponents together. All right, so a to the m plus n. So let's try it. So we have 5 to the 3rd times 5 to the 5th. So 5 to the 3rd times 5 to the 5th is 5 to the 3 plus 5, because I have 3 of these as a factor and 5 of the same thing as a factor. So I'm adding the 3 and the 5 together, and I have 8 of them as a factor. So this would be 5 to the 8. Now this is called exponent form. There's another form in a little bit, which we'll get to, but that's not where we are yet. So just to prove it to you is, what is this? It's 5 to the 3rd and 5 to the 5th. And when I multiply all them together, what do I get? I get 5 to the 8th. Now, it does not have to be a positive integer. Yes, you can have fractions, and yes, you can also have negatives. So it doesn't matter. That's what the a over here represents. Okay, whatever happens to be being raised to the power. So here we're raising negative 5/6 to the power. So it's negative 5/6 to the 7th and negative 5/6 to the 4th. Well, what does it come out to be? Whatever's being raised, which is negative 5/6. And again, we do the same thing, 7 plus 4, or negative 5/6 to the 11th power. Okay, let me move myself. Okay, so now we're going to switch it up slightly. So this is different than this. Okay, so if you notice, over here we had the same power being multiplied, the same base being multiplied by each other. Here, what we're doing is we're taking a base and a power and raising that whole thing to a power. So this is a lot similar to what we did the other day. Whatever's in here gets multiplied by itself 3 times. So what happens to be the base in this case? 3 to the 4th. So this means 3 to the 4th times 3 to the 4th times 3 to the 4th. Well, what does that look like? 3 to the 4th times 3 to the 4th times 3 to the 4th. So this looks like 3 to the 12th to me, and should look like that to you, but let's do one step before that. Isn't this 3 to the 4th plus 3 to the 4th plus 3 to the 4th? So isn't that 3 to the 4 plus 4 plus 4? Oh, wait a minute. Is that what we did on the other side? Wait a minute. Isn't 4 plus 4 plus 4 repeated addition, which also happens to be multiplication? That would be a yes. Okay. So it comes out to be 3 to the 12th. So, yes, multiplication is just adding over and over again. Kind of fun. So what's the actual algorithm here? All right. So this one looks different than the other one. I'm going to go through a review at the end. The other one was a to the m times a to the n. This is different. This is a to the m raised to the nth power. So what do? Super simple. Multiply the exponents together, and that's what it becomes. Why? Because you're doing this that many times. So since you're repeatedly adding the same thing that many times, it becomes multiplication. Makes sense. So let's try it. 7 to the 6th to the 9th power. So that becomes 7 times 6 times 9 power. Okay. And now 6 times 9 is 54. So 7 to the 54th power. That's all. What does that equal? I don't know. Something utterly massive. Doesn't matter right now. Okay. So can you do this with variables? Of course you can. B cubed to the 9th power. Nothing different here. All right. So just because this is a B or a 3 or an 18 or a 97 or a negative 1/4, doesn't matter. You still do the same thing. So it's the base and then the power times the other power, the exponent times the other exponent. So 3 times 9 is 27, b to the 27th. I know, really. It's that amazing. Well, we're going to look at it in a slightly different way. So now, instead of it being an integer or a fraction raised to a power, or just an exponent raised to a power, we're now doing a number with an exponent. It could also be a number with a variable. It could be multiple variables, whatever it is that we're going to have. Okay, so what does 2m cubed mean? It means 2m times 2m times 2m. Now, just using the commutative property, we can switch the order around. So this is 2 times 2 times 2 times n times n times n. Well, this looks like 2 cubed to me, and this looks like m cubed to me, and I'm multiplying them. So 2 cubed, m cubed. That's it. So again, this power gets multiplied by each of these. Now, this did get multiplied by a power. What is my exponent with 2 here? The exponent is 1. What's 1 times 3? 3. What's my exponent with m? 1. Remember we said that if it's not written, it's understood to be an exponent of 1. So 1 times 3 is 3. So we're still doing the multiplication. It just looks a little bit different. Okay. So the algorithm is if you have an equation inside the parentheses being raised to a power, it becomes whatever that first term is raised to the m to whatever that exponent power is. And then the second part raised to the second. Okay. Raised to that power. And that'll make sense in a second, right now. So we're going to do these two different ways. We're first going to write it as a power, and then we're going to look at it, what it would look like if it was simplified. So again, 8 has an exponent of 1. 1 times 3 is 3. 8 cubed. K has an exponent of 1. So 1 times 3 is 3. So 8 cubed, K cubed. Now let's try it with a fraction and 2 variables. Ooh, I'm tricky, aren't I? Yeah, right. So anyway, this is going to be 1/4 to the 7th times g to the 7th, right? Because the exponent here is 1. And h has an exponent of 1. 1 times 7 is 7. So this is 1/4 to the 7th times g to the 7th times h to the 7th. So anytime you see written as a power, you'll write it like this. Okay, like that or like that. Absolutely amazing. Now, if it uses the word simplify or simplest form, what we'll do is, again, we'll first start with this is 8 cubed, k cubed, but we can solve 8 cubed. Remember we did this last time. So 8 cubed is 512, so 8k quantity cubed would be 512k cubed as a simplified form. Same thing with this one, okay? So this was 1/4 to the 7th, g to the 7th, h to the 7th. We can take 1/4 to the 7th power. It's some wacky number. It's called 1/16,384th. How did I do that? A calculator. Doesn't matter. Okay, you don't have to do that in your head. Use your calculator. G to the 7th, and H to the 7th. Whoa, that's amazing. Okay. So let's just do a quick review of the 3 different things that we did today. So the first one was if we're multiplying a common base raised to a power. If it's a common base being multiplied by each other, you keep that base and then you add the powers. If you are taking something and raising it to a power, you multiply the exponents. Right? So you see the difference of what this looks like and what this looks like. This becomes that, that becomes that. And the third one we did, now B again is just representing some other thing. You're just multiplying 2 things here. Could be 2 exponents or a number and an exponent. Again, you just raise each one of these to that power. Okay, so A to the M, B to the M. And if it's a number and it asks you to simplify, you just put it in your calculator and solve it. If you guys have any questions, go ahead, reach out to me. I'll have GoGuardian on with the chat function open. If not, have a good day. Bye.